Okay, I think we can go ahead and get started. So today we're going to be talking about Pulumi and how we can use Pulumi in conjunction with AWS in order to manage and deploy our resources. So we're Be Cloud Ready. We're a startup company that focuses on cloud architecture, as well as branching off into training corporate clients, students, as well as we also do a little on the side consulting as well. So as you can see, we've had a couple of big corporate training clients, along with Calibra, Capital One, Bank of America, and many more. And we also do some tech corporate training as well. This is with like a group of people who are just trying to learn new technologies. So let's get started with Pulumi. So before we even talk about it, we need to understand what Pulumi is. So Pulumi was built open source, and it is a modern infrastructure as code for developers and infrastructure teams. What this essentially means that it will allow you to build, deploy, and manage modern cloud applications and infrastructure using familiar languages, tools, and engineering practice. And you may be thinking this is very similar to something like Terraform, but where Pulumi differentiates itself is that Pulumi has support for multiple languages, unlike Terraform, which uses its own proprietary language. Pulumi also supports multiple cloud providers, so you can talk about AWS, the GKE, um, Azure, anything. Pulumi will support as well. So to go over the benefits of Pulumi, Pulumi is very simple and it's very compatible. Like I mentioned before, you can use it on a variety of different um, cloud technologies, and it's simple in the sense that you will already be somewhat familiar with it if you know a programming language. It doesn't require you to learn a new language all over again. Something like Terraform will do, and yeah, you can just go ahead and get started right away. And Pulumi brings the cloud closer to application development. So one of the things, there are many benefits of clouds, something like AWS. It allows you to have computers remotely, virtual private connections, all of these things. But one of the biggest hassles is managing all these different services. So if you were normally using AWS, the only way you would be able to manage it is to actually log on to the AWS console and then go through their GUI. And the GUI, although it looks nice, it's not really practical for long term, because let's say you had 400 servers, 400 gateways, all of these things. It's going to be a nightmare to manage. This is where tools like Pulumi come in, and you can use code, and this is why it's called infrastructure as code. You can write code to help you manage all of these services in the cloud, and it's much faster and easier than using a web GUI. So yeah, that's what I mentioned about use engineering practices, which infrastructure. So you can also use Pulumi alongside with CI/CD pipelines like Jenkins to even automate it even further. And one of the best things is it's collaborative, so one person can write the initial part of the code, and if there's any updates that need to be made, another person can take the code and write on top of it. So it stacks up, and you don't two people don't have to go into the GUI and figure out what one person did and then make changes based off that. You can easily see on the code what someone did, and then you can write on top of that. So let's compare Pulumi and Terraform. So Pulumi is very similar to Terraform in that you can create, deploy, and manage any infrastructure on the cloud using code. Except the biggest difference is Terraform forces you to use a custom programming language, their own programming language. The other one is Pulumi, on the other hand. It will allow you to use familiar general purpose languages and tools to accomplish the same goals. For example, you can use Python or JavaScript to write the code on Pulumi. Excuse me. They're both open source, and they both have state management built into the application by default. So here's an architecture diagram of how Pulumi works. So the Pulumi is based off of its CLI and its engine. And the way it works is whatever programming language you choose to write it as. In this case, in this example, we're using JavaScript, our index at JavaScript. It's going to read the index.javascript and take any new resources you want to create or modify or delete even in any way, and it's going to write a new state and store that state for future use. That state will contain all the resources you've created, all the modifications you made. So what Pulumi will do is it will check against the state to see if anything new is being created or updated in any way, or even deleted. And based off of that, whatever new thing that you are trying to make, it will run the engine and go ahead and create those new services onto your providers of your choice. So that could be AWS, Azure, Kubernetes. So once again, in a very basic nutshell, how it works, the CLI reads the index.js that you wrote. It checks against the last deployed state to see what changes are made. Once it discovers those changes, it will go ahead and push those changes using its engine to create, update, and delete resources on your cloud provider. So the language host is responsible for running a Pulumi program and setting up the environment where it can register resources with the deployment engine. This is one part of, these are the different parts of the Pulumi, and one of the parts is language host, and once again, it's responsible for running the program and setting up the environment where it can register the resources. So basically anything from AWS resources, the language host is responsible for setting that up. A language executor will launch the runtime for the language that your program is written in. So the language host is on the cloud provider side, the executor is on your local side. So if you write it on Python or JavaScript, the language executor will make sure that it will be able to read the program on whatever language you have written in. And then finally, a language runtime is going to be responsible for preparing your program to be executed, as well as observe its execution. So it's like any runtime. It's just going to make sure that whatever code you have deployed, it works, basically. Then we have the deployment engine, which is responsible for computing the set of operations which are needed to drive the current state of the infrastructure into the desired state expressed by your program. So current state, it means what your architecture in the cloud looks like right now. You want to make some changes, you write it in the program, you deploy the changes. The language host will be, sorry, not language host, the deployment engine will be responsible for making sure that those changes actually take place. So when a resource registration is received from the language host, the engine will consult the existing state to determine if that resource has already been created before or not. And there's two options in that case. If it hasn't, then the engine will reuse the resource provider. In this case, it could be for AWS in order to create a change in it. And if not, like if the resource is already created, then the engine will determine what the state, if any changes to that resource have been made and needs to be applied. So there's two ways to go about it. Let's say you want an EC2 box on your AWS server. First, when you deploy it, the engine will check the state to see if the EC2 box already exists. If it does, it will check if any changes to configuration has been made and apply those changes. If the EC2 box does not exist, it will go ahead and create that EC2 box for you. And then the resource provider is what's actually calls the AWS API to create the resources that you need. So it's made up of two different pieces. The first piece is a resource plugin, which is the binary used by the deployment engine to manage the resource. And then you have the SDK, which provides binaries for each type of resource the provider can manage. Here's a very simple example. In this case, we're creating a new S3 bucket. So we go ahead and set some constants, the media bucket and the content bucket. And these will refer to new S3 buckets. So the first one would be the media bucket, and then the second one would be the content bucket. So this is exactly how you write a Pulumi program, and it's going to create two buckets, and we're going to run the command Pulumi stack init my stack, and this command was going to create a new stack, which is kind of like a new folder where everything is going to be tracked, and it's going to store the new state. Then you're going to run Pulumi up, and since this program is written in JavaScript, Pulumi up is basically the run, like setting Pulumi to go ahead and execute my instructions. Since this program is written in JavaScript, the Pulumi CLI will launch the node language host and request that it execute the program. So as the program is being executed, the first S3 bucket is going to be constructed, and then the language host is going to send a resource registration request to the deployment engine and continue executing the program. So this doesn't necessarily mean that the bucket is created. The resource registration just simply means that the instruction to go ahead to create the bucket has been sent. The bucket creation could take a couple seconds. And it depends, like, EC2 boxes might take 20, 30 seconds. Something more resource intensive, like maybe an EKS, like a Kubernetes cluster, might take a couple minutes to create. So it's going to check that the last deployed state has no resources. That's because this is our first time going ahead to create an S3 bucket. Then the engine will determine that it actually needs to create this media bucket, which is the S3 bucket resource. And in order to do that, it's going to use the AWS resource plugin in order to create the resource. The AWS resource plugin is going to use the AWS SDK, which is like the way to access the AWS API in order to go ahead and create it. Now, while this first bucket is creating, the engine will simultaneously continue working on the second bucket request as well. And this way, it goes by much faster instead of doing it one resource at a time. And eventually, the program will complete. You can use the command stack and then the name of the stack in order to check the state. So you can see that the media bucket has some extra like numbers and letters to it. And this is due to an auto naming function that comes built in with Pulumi. So we talked about how to create. Let's talk a little bit about how to delete. So Pulumi will execute resource operations in parallel whenever possible, but understand that some resources can have dependencies on other resources. And if this is the case, then it will go ahead and create the resource that is prioritized the highest. So by default, if a resource must be replaced, then Pulumi will attempt to create a new copy before destroying the old one. And this is helpful because, like I mentioned before, some resources have dependencies. And if you delete a resource that has a dependency on another resource, that second resource would also fail. This is why you create the copy of the resource so any dependencies are satisfied, and go ahead and update it. Once it's updated, then you delete the copy. On that way, there will never be a service down. Okay, and we're going to go ahead and show you a demo. So let me go ahead. So this is my AWS account. As you can see, currently I have no instances that are running or anything like that. So what I have done is we're going to create a very simple EC2 box on the cloud using Pulumi. And all that EC2 box is going to do is create a web server, which is going to return hello world. So we'll take it a couple steps at a time. First things first, what we need to do is we need to actually go ahead and install Pulumi and configure your AWS credentials. So don't worry about trying to follow along in this demo. This will be recorded so you can watch it at your own time and go at your own pace. So I have already installed Pulumi and my AWS credentials are already configured in the .aws/credentials file. So I should be good to go right now. Let's take a look at a couple of the files that are already here. So this is the YAML file, which is just going to give a name to your project. It's kind of like a description type thing. Then you have the requirements, which installs Pulumi, and then the AWS plugin for Pulumi as well. So this way that Pulumi can create resources on AWS. And we have this main.py. This is the Python file which I'm going to be coding in order to create the instances that I require. Okay. This VNV file is if you have virtual environments. I'm not using virtual environments, so we don't need to worry about this. Okay, so actually, in order to get this folder, what you needed to do was you got to make this web server folder, and then all of these files inside the folder can become, if you run this command, Pulumi new AWS Python, and then give the name of your project. So let's say my project or something. So this command right here, spell project wrong, will actually go ahead and create all these folders, because this project is one of the startup projects on Pulumi website for you guys to learn how to get familiar with Pulumi. So once you go ahead and have all of these, let's go through this code and figure out what's going on. So first things first, we are importing all the files and the packages that we need. And then after that, we're setting the size to T2 micro. So EC2 instances come in different sizes. The T2 micro size is free tier eligible, so this won't cost you any money. And we're also getting the AMI, which is just the image of the like, it's kind of like the operating system. So it doesn't really matter what this is, but I just took what the default one, which is right here. Next thing, this is important, is we're creating a security group. So by default, if you create an EC2 instance, that EC2 instance won't have access to the public. So there's no way from the outside you can connect to that EC2 instance. So what we're doing first is opening up port 22, which is the SSH connection. Sorry, which is the SSH connection for that EC2 box. And that way we will be able to connect to that EC2 box. We're going to go ahead and create the EC2 instance as a server type web server www. We're setting the instance type to T2 micro as we wrote in the variable earlier. And we have our VPC security group as this security group as we wrote earlier, and the AMI as this AMI, which we wrote earlier as well. Okay, and then this is just calling the like once it's finished, it's going to go ahead and print you the public IP and the public host name. So as I mentioned in the slide before, in order to run a Pulumi, what we need to do is type in Pulumi up. So, okay, we have to create a new stack, and I'll call it dev for this. So we created the stack dev, and it's going to go ahead and run this program. So this does take a couple seconds because it's creating an EC2 instance. So we'll give it a couple seconds. Okay, so my AWS access keys, secret access keys, there's something, an error. I think what I have to do is I have to export. Give me 1 second. Let me go ahead and paste this command. So what I'm doing right now is I'm setting the AWS profile to my profile, which has my credentials on it. So let's go ahead and do that and see if this will work now. So the error was unable to discover the access, and I just, pointed Pulumi to my profile, which has the access. It's still not working. Okay, give me 1 second. Okay, what I'll try now, I'll just delete this, and I'll start from the very beginning and see if that works. Okay, so from the beginning, I'm going to go ahead and create that folder again. Change to the web server. No, this is not right. Give me a second, guys. Okay. There we go. So I went ahead and created that, and then I'm going to go ahead and create a new Pulumi project. So I'm running this new AWS Python and giving it a name. I'll just leave it as my project. Project with this name already exists. I'll call it, say, AWS. Okay. Yeah, US East 1. These are just running through the configurations. So this step will go ahead, now it's collecting pip and it's going to install Pulumi in this new virtual environment, which is just created. So let's see. Okay, project is ready to go. Let's take a look at our web server. Yeah. So yeah, you can see it automatically creates a new simple sample project to install an S3 bucket. Why don't we just go ahead and try this? And if everything is right, we should, these S3 buckets should be created. Let's see if this works. Okay, it looks like I have an issue with my AWS credentials. Since this is being recorded, I can't share the credentials here. Let me try one more time to see, maybe this will work to set the config. Try one more time. Okay, this time it worked. I'm not sure why it wasn't working before, but it has access to my credentials. So yeah, I'm gonna go ahead and create. You can even see it's saying it's trying to create an S3 bucket called my bucket. So I'm gonna go ahead and create this. And what I can do as well is go ahead and show you on S3. We should see a bucket called my bucket or something similar with because it has auto naming turned on. It hasn't created yet. Let me just make sure it's still creating. Okay, now it says it's created. Let's go ahead and open that up and refresh the page, and we should see. Yeah, you can see this my bucket is here. Now, yeah, that's a very simple one, but what we're going to try and do now is get that web server working on the EC2 instance. So it should be working now. I'm going to go ahead and just copy that code that I had earlier. Give me 1 second. So this is the same code that we went through last time. And now you see, I mentioned before about the status. It keeps a track of what resources are available. So this S3 bucket was created before, so it should keep track of that. And um, when I replace this Python file, there's no mention of the S3 anywhere here. So Pulumi is going to think that we want to destroy this S3 bucket because it's not mentioned anywhere here and it exists already in its stack. So it's going to read that, see that the S3 exists, but we're not mentioning the S3 anymore. It's going to delete the S3, as well as go ahead and install the EC2, as well as the security groups and everything that we want to add. So if I go ahead and run Pulumi up, let's see, it should destroy the S3 bucket, as well as create the new EC2 instance for us. Yeah, you can see the output is the bucket will be destroyed, and then right here, the bucket will be deleted, and the EC2 instance as well as the EC2 security group will be created. So I'm going to go ahead and accept this and wait for this to take place. Okay, it's going ahead and running now. So the security group was created. The EC2 instance is about to be created. And after that, the bucket will be deleted, and I can show you that. So let's go back over to the EC2. And I don't have any EC2 instance currently. You can see none of them are running. But once Pulumi finishes, it should create an EC2 instance here. It still looks like it's still creating. Let's give it some time. Yeah, it created. Yeah, it's finished. So now if I refresh this, I should see. There you go. The EC2 instance is running, and we have a instance type of T3 micro, just the size, and everything is there. This is the public DNS, the IP, and actually this should also get printed here. Yeah, the public host name and then the public IP. So all we did up to this point right now is create the EC2 box. We haven't added the server yet, which will print hello world. So that is our next step, what we're going to do. Another command that is very helpful is if you run Pulumi stack, this will give you a rundown of what you have done so far. So you can see this, the owner is me. I have a security group as well as an instance up in this current stack, and then the outputs as well. So if you have 100 different host names and stuff, you can run Pulumi stack to find the output for all of them. Okay, so the next thing we're going to do is add that web server onto our EC2 instance to print hello world. So go ahead. So first thing, we need to update our security group because currently right now we just have access to SSH into it. But what we need to do also is open up port 80. And what port 80 does is allow an HTTP connection, and this will allow us to access our web server in order to print the hello world message. Following that, we need to actually enter the hello world message. So this piece of code right here is just a very basic script, which is going to print hello world in an index.html file, so that whenever we access our web server, it's going to print hello world. And this is the web server that is going to be running on port 80. And as you know, we just opened up port 80. So we also need to inject this data into the web server itself. So we're going to add another flag here, user data, and this user data is getting entered into here. And that's all that's to it. So I'm going to save this file. I'm going to run Pulumi up. And let's wait and see what happens. Okay, I'm going to go ahead and say yes to this update. So you can see instead of running, it's actually creating a replacement. And that's because we've changed the once an EC2 box has been created to inject more scripts into it, it needs to run it again because the scripts only run on the creation. And this is why instead of updating, it's going to delete the old one and then create a new one. Yeah. And as I mentioned before, creates it creates the copy first, and now it's deleting the original, just in case there are any dependencies. All right, looks like it finished, and this is the new host name right here, and then the new public IP right here. So now theoretically, if we go ahead and do a curl onto that host name, we should be able to see hello world. Now this might take some time for that web server to get up and running, but we can try it. What I'm doing right here is I'm actually using a variable instead of entering the IP address by itself. I'm just saying take the output of the public hostname from my stack. So let's see what happens. And yeah, it looks like it created quickly. And when I access that EC2 box, I get a response message of hello world. And yeah, that pretty much covers this demo. Oh, one more thing. So after you have finished creating all your resources, let's say you want to go ahead and clean up everything, all you need to do is run pulumi destroy, and this will destroy everything and clean up everything on your AWS account. So yeah, that covers pretty much everything in the demo. And yeah, you guys can go ahead and sign up for our next webinar, and I will leave the floor open to any questions at this point. If there are no questions, you guys feel free to drop out, and thank you for joining us today. Okay, I see a question by Sheila. Does Pulumi have any similarities to Tanka? I don't know too much about Tanka, but what I do know is that it has related to Kubernetes, and it's kind of like a deployment system, if I'm not mistaken. I guess in a way, Pulumi is similar, but Pulumi focuses more on cloud, not just a specific application like Kubernetes, but just cloud architecture in general. So Pulumi, I guess you can say Tanka is very specialized. Pulumi can even create a Kubernetes cluster on AWS, GKE, whatever you want. Not GKE, like Google's cloud and Azure's cloud. So yeah, Pulumi has the ability to do what Tanka does, just not as specialized as Tanka. Okay, I don't see any more questions. So if that's all the questions for today, then thank you so much, guys, for joining us, and I hope to see you guys next time. Oh, I see one more question. So Josh is asking, can Pulumi create skeletons templates from existing EC2 objects? If what you mean by templates by EC2, from existing EC2 objects is like objects that have been created earlier, not using Pulumi, I do not think Pulumi will have access to those. Only resources that are created using Pulumi, Pulumi can access. This is the same way Terraform works as well. It keeps track of whatever it creates, and that's what you can use. If there is a way to modify the file to include other objects, that could be a possibility, but I'm not sure if, like, I don't have any experience with that. I mean, something similar to AWS select command, describe instances, generating JSON from an existing EC2 instance, for example. Yes, then yeah, you should be able to I'm not sure what the exact command is, but once again, all the objects that are created from Pulumi, you should be able to access. And I'm sure there's something similar to describe instances, but I can't say off the top of my head what it is. Okay, thank you so much, guys. I'm gonna go ahead and end the meeting now.